Good afternoon and welcome back to the workbench. So today you may notice that the lighting here is not particularly good, and that's because I've got a problem with my lights and that they're not working. So for anyone who doesn't know, I've got three sort of strips of LED lights that go along here above my workbench, and they're all fed with a 12-volt power supply, which is in fact this one here. And you can see by the fact that I've pulled it apart that obviously there's something wrong with it, and that is indeed the case. It would appear that it has some kind of temperature dependent fault on it, because as the weather has been getting colder and autumn is coming in, the thing has stopped sort of powering up immediately when you plug it in. And I remember last year in the middle of winter it would possibly even take half an hour before it would actually turn on after you plug it in. So some kind of thing going on here that it needs to warm up before it starts working, and that's not an uncommon thing with electronics. You can quite often get temperature sensitive components that go faulty and only work when they're hot or only work when they're cold or whatever. And I've actually done a couple of videos kind of like that before on some switch mode power supplies where it turned out the control chip was overheating. Ones with integrated MOSFETs seem to do it more often than not, but yeah, the chips would overheat, shut down, and then the power supply would just turn on and off over a period of like a minute or so. I think a monitor I had, LCD monitor, you'd power it on, it would run for like a minute, the chip would get too hot, it would shut down, it would stay off for about 30 seconds, and then the cycle would repeat. In this case it's a bit different. This thing just won't turn on at all when it's cold. And so I mean, with that symptom, it's you kind of know where to start. Something is not working when it's cold. So basically, the trick is to heat things up and cool them down, and alternate between the two until you sort of pinpoint what it is. So to that end, you will want some freeze spray. Preferably with a wide nozzle on it and also a narrow nozzle, and also some sort of hot air tool. So surface mount hot air gun is really useful. So I've got this, I've got a fine nozzle I can take on and off, but yeah, you can kind of use a hairdryer, maybe a cardboard tube or something, but it's not going to be as accurate. A small nozzle like that is much better. But anyway, so first of all I looked at it and I thought, well, okay, so where shall I start? Well, I figured, we're going to test to see whether we're getting any power to the main filter capacitor, and I think that's kind of like the first best test to look at before you try anything else, after you've just verified the fuse hasn't exploded or anything like that. I mean, in this case, it's unlikely because it does power on when it's warm. It just doesn't run when it's cold. So nothing's exploded. It's just a bit funny. So yeah, but with most power supplies, the best thing to do is check that. So that'll tell you if the capacitor's okay, kind of. It'll tell you if the bridge rectifier's okay at least, and everything before that. So I plugged it in. It didn't turn on, obviously, and then I checked the voltage on the filter capacitor, primary filter capacitor, get 325 volts, which is what you'd expect. So if that voltage was low, you could say, well, maybe the capacitor has lost capacity, it's gone high ESR. Or there's some kind of load across it that's, well, unlikely. If there was a high load, you'd see something going on fire, most likely, or the fuse blowing. But bridge rectifier, for example, could be going intermittently open circuit. Unlikely. They usually go short circuit and just blow up. But it could be, maybe something's going open circuit when it's cold, so it's not getting any power. Well, that's obviously not the case because you've got 300 volts across the capacitor, even though the power supply wasn't actually running. So kind of forget all that, say, well, that seems to be fine. So then you kind of look at the design and say, okay, how's this thing supposed to work? And this, in fact, has not a common thing. It's quite sort of strange. It's not an old supply, and yet it uses what seems to be a kind of a 2-transistor oscillator. So it just self-regulates and self-runs. There's no control IC at all, which is surprising. It does have a feedback from the secondary side with a TL431 or something over here, and it's got an optoisolator that drives back to the primary side and does that. So it's a pretty good design, but yeah, they haven't used a control IC. I don't know why. That doesn't matter though. But what it makes me start wondering is whether or not this has a fault on the primary side or the secondary side. Now, because this is not using an IC, that's a good question. Now, from what I know, most control ICs for switch mode power supplies, they take an input from an optoisolator for feedback, for voltage control and everything. And they also use that to sense short circuits and overloads and stuff as well to some extent. But basically, what they all typically tend to do is they will go into a sort of a shutdown and restart loop if they detect a short circuit or something quite similar to that nature. And if there was a fault in the secondary side, such that, say, the feedback circuit, say the TL431 went short circuit, and the optoisolator is just turned on fully the whole time, that would be as if the voltage on the output is always far too high, and the feedback circuit is telling the primary side to turn the drive down. The voltage is too high, start turning down. Now, with an integrated circuit control chip running everything, you would expect it to sort of go into some kind of over voltage protection mode where it would probably, well, it may power cycle, it may not, or it may at least try to start up. It may at least start up once as soon as you apply power, and then it may say, oh no, there's an over voltage problem, and then it just shuts down until you reset it by clearing power and then repowering it again. Well, that's not the case here. It doesn't even start up at all. It doesn't try anything. So, because of course there's no intelligent control for that, what you generally have is the secondary voltage sensing drives the optoisolator, and that sort of influences the base drive to the transistor. So you could imagine, for example, if the optoisolator was fully on, it could be dragging the base of that transistor down so low that there's not enough voltage really to even start it running at all, which would make sense. So yeah, so the symptoms we have, it could be the primary side, it could be the secondary side, I don't know. So you kind of, first of all, you want to start there, see what side is it, and we know it's temperature dependent, so we can just take some freeze spray and start freezing things. So I kind of figured, well, I'll go with the primary side first, because why not? It's more likely, because stuff on the primary side runs harder, runs hotter, is more likely to fail. Secondary side, not so much, except for maybe the output capacitors, which this could be that issue. Sometimes with a power supply, the capacitors are faulty, they're going high ESR, they work okay when they're warm, but they don't work very well when they're cold. But that's unlikely to cause a complete lack of power up. More likely, if the capacitors are high ESR and they're not working properly when they're cold, then the thing is probably going to run, but the voltage may be unstable, or as soon as you give it a load, it just goes down to really low voltage or something, or it just has high ripple, really noisy output. Unlikely to be something like this where it would shut the whole thing down, or not even let it start. In a situation like that, you might expect it not to work into a load, so with the lights plugged in it might not work at all. You unplug the lights, it might work. Obviously I've tried this without a load and it doesn't work in that case either, so unlikely the capacitors, and they're one of the well-regarded Japanese brands, Nippon Chemicon I think, so unlikely, and they're not a series that's known to go bad, so yeah, it's sort of unlikely, and the fact that the thing works perfectly when it's running, it's sort of, yeah, doesn't really make sense. So what I did first was I just froze the entire backside of the board in the primary area around the switching circuitry and just everything here. I figured, surface mount stuff here, could be like a cracked ceramic capacitor or something, maybe, I don't know, so I figured I'd just start with that. So I froze the entire section here, and it didn't work. nothing came up, which made sense. So I started heating it. He started from this end, started heating with the hot air. As I got closer to this side, it turned on. So I kind of did that a couple of times and got it down to it's really in this area here, right around the switching transistor, the main switching transistor. I mean, like I said, there's probably two of them here. I think one to make the oscillator, but the main one that actually switches the primary to the transformer. As soon as I started heating around that area, the supply would come back on. So it really seemed to be something in that area there. And I thought, well, it could be the transistor itself. But that seems unlikely because, I wouldn't really expect that to happen. I'd expect if the primary transistor went faulty in some way to that extent, I would expect it just to blow up rather than not turn on randomly. I mean, anything's possible, but it seems unlikely. Those things, it's handling 300 volts and switching pretty fast, probably, 20 kilohertz or something. If something's going a bit wrong there, it usually just explodes. So I figured it's probably not that. So I froze and unfroze the primary side there a few times on the back side and couldn't really get any results. It didn't really seem to be this diode and resistor, which are part of the feedback. I thought, that could be it, because like I said, my theory was, maybe the feedback is pulling the base drive right down and it's not doing anything. But focusing on this area didn't seem to make any difference, and these diodes and everything tested out okay, so nothing going short or open when it was hot or cold, so didn't seem to be an issue. So I started going on the other side of the board where there's a ceramic capacitor and two MKT box capacitors, and then there's a coil which obviously is part of the self-resonating oscillator circuit. And I stuck in my little nozzle here and started spraying around. So I sprayed this MKT here and I sprayed this coil. Could be either one, they're right next to each other, so it's hard to say really. If I plug this in, if I plug it back in and then blast it with hot air, suddenly it comes on. Could be that coil, could be that capacitor, could be a bad solder joint on one of them. The joints don't look bad at all, but yeah, you never know. So what I'm going to do is check to make sure this capacitor is discharged. It's unplugged, yep. Okay, got 4 volts on there, that's pretty good. So yeah, the step here, I guess, is to unsolder this. I'm going to take the coil out and that capacitor next to it, because it could be either one of those. And yeah, I'm trying to see. I'll test the capacitor, test its capacitance and everything. I'll freeze it and test it and see if it's gone open circuit or something. Same with the coil, I guess. I might take the heat shrink off the coil and see if there's any, if one of the leads falls off or something, or if there's a crack in the wire somewhere. But again, it might just be a bad solder joint, so who knows. I'll desolder those and we'll have a look in depth and see if there's anything obvious with either of them. Alright, well that was quite interesting. I think I found the problem, and it wasn't the coil, as I thought it might have been. I pulled that out and I tested continuity and I froze it, and it still read perfectly fine, so no issues there. I pulled the two capacitors that were right next to it, and neither of those seemed to have any issues, whether they were hot or cold, but I did notice after I pulled the main filter capacitor out, which I had to do to get access to the other ones, and once I'd got everything out, I noticed that the optoisolator had some pretty horrible looking pins on the transistor side, on the primary side. So you can see in this close-up photo they're pretty scungy and awful, and quite corroded, and there's also some corrosion on the circuit board as well. It sort of leaked through the hole. You can see this kind of black ring around the one of the pins, so yeah, it doesn't look too good. So I cleaned up the pad and everything and resoldered it on the top side to make sure it had good connection, because it's a through-hole board and a two-layer board, and they've got that particular trace is soldered to the top side, just in case it was a bad connection, but it doesn't seem to make any difference at all. Still does exactly the same thing, but if I freeze the optoisolator I can stop it working, and if I heat it up again it works. So it looks like I kind of just got confused with the coil. I don't think it was the coil at all, because yeah, it looks far more likely it's the optoisolator, considering it's got signs of actual damage. So I'm guessing some corrosion has gone in through the sort of leaked in through the side of the pin, and it's corroded maybe the bond wire that goes from that pin to the die of the transistor anyway. So probably there's a intermittent connection there that only works when it heats up and expands, and you know, the metal pushes together and it creates a contact, and other than that it goes open circuit, I suppose. That's what I'm guessing is the problem. So I'll have to probably buy a new optoisolator for it to get it working properly. I don't have any that are suitable. It's a, what was it? It's a CQY80NG. You can buy them for 40 cents off RS Components, but you have to buy them at least 50 of them. And Farnell has them, I believe, for $1 each, but of course you have to pay a minimum either $15 for shipping, or you have to get free shipping by ordering, you know, over like $50 or something. So not particularly useful. I mean, useful, but I won't be getting one anytime soon. I'll have to wait till I put an order together and I'm buying some other stuff, but that's okay. I mean, like I said, the thing does still work. It just have to plug it in maybe up to half an hour before I actually want to use it. So yeah, not completely hopeless, but yeah, until I make another order from Farnell and I buy a couple of these, then won't be fixing it just yet. I could get off eBay. They're about $6 each, but I don't know. Don't really like the idea of that. You know, it's a waste of money. I don't need it that quickly anyway. I mean, I have other power supplies I could just swap out for this if it completely dies or blows up or something. But yeah, I'll just leave it as it is, and I'll wait till I order one of these from Farnell next time I do a big order, and all that, so I don't have to waste money on buying a whole lot of them or spending 5 times the price on eBay and waiting ages anyway. So, you know, makes more sense to get it from here. So yeah, there we go. But that's the kind of thing you can expect sometimes. You get faults that act on temperature. In fact, I can plug back in and prove that it works now. In fact, there we go. We can get some decent lighting. So yeah, it's all running now. But yeah, it's not going to work perfectly until I replace that optoisolator. I think that seems to be the problem. Yeah, I mean, it's quite strange because this board is really clean. Otherwise, it's been manufactured really well. It's very good quality, and you know, they've used high quality capacitors and really decent components, and you've got a very nice input filtering stage, and everything's really good. So yeah, I'm surprised, but maybe it's the thing was contaminated during manufacture or something, and over time it's just leaked in, corroded the pin or bond wire or something inside. I did replace a corroded IC, like an AND gate or something, in this DSO here. It was corroded from battery corrosion because of the internal NiCad battery, and even though the rest of it looked perfectly fine, you could see there was some corrosion on the pins, and the chip was just sporadically oscillating and causing all sorts of havoc. So, you know, replacing it fixed the problem, but the only indication that it was faulty was just some minor corrosion on the pins, which, you know, from the outside you wouldn't think was any big deal, but clearly it had gone in far enough to cause issues. It could have leaked, you know, wicked up the bond wire and gone into the die or something, and, you know, caused like some kind of short circuit or corrosion or whatever. I don't know. You know, it'd be interesting to sort of open it up, you know, decap it or something, and try and figure it out, but probably not really that easy. And, you know, during that process you may remove the corrosion or whatever could be. So maybe, if you could X-ray it or something, but who knows. The optoisolator is the only component there that has physical signs of actually possibly being damaged. So yeah, but it's not easy to see because it is buried in behind everything else right down the bottom. So it wasn't until I took those other components out that I could see more clearly that it was obviously had some corrosion on the pins, and considering everything else in the power supply is perfectly clean and really good quality and really well put together, that kind of stands out, as an issue. So yeah, I suspected that. Alright, so I've finally got the new optoisolators here. I've got a bunch of them here, which I got from DigiKey, because that was the last place that I ordered some parts from, and I figured, well, I'd chuck a few of these in with the order, so I did. So I'll just do the replacement of that today. So I'm obviously using the lights at the moment. I'll have to take this power supply off and take it apart again to do that, but yeah, I'll do that in a second. So hopefully that will fix the problem. We shall find out. Alright, so let's get this thing open again. So for anyone who's interested, this is an APS, I think it's Advanced Power Systems or something. Oh, there we go, Advanced Power Solutions. It's an AD-740U-1120, if that means anything to anyone. There you go, 12 volt, 3 amps. It is a pretty good quality power supply. As I said before, apart from that random corrosion on that optoisolator, which is very strange considering how clean everything else was. Anyway, so there's a screw under the label here at the top there, and there's another screw under each of these feet. There's 2 feet there, nothing here. These are just little bump standoff things, but there's a couple of feet here. I'm just going to dig these out with a pin. Oh no, hang on, there is no screw there. Okay, I must have already taken that out then and not put it back in. Never mind. Okay, so I think that was it. Yeah, so let's see, that should, well, there we go, that comes straight off. So yeah, there are 2 screws under there, but I obviously have left them off, which kind of makes sense. So there we go. I mean, here it is again. You've seen this before, maybe not close up because the previous segment was a bit not close up, but there we go. I mean, that's the general thing. It's a pretty basic little power supply. Like I said, it's self-oscillating. You've got a main switching transistor there, and then there's another transistor somewhere else, I think on the other side of the board, surface mount. So let's see, first of all, let's just take this out here, and they do have this sort of metal shield plate thing at the bottom, so you have to desolder these 2 wires and take this off, so I'll just be doing that. I should have turned my soldering iron already. Alright, so getting this off is a fairly straightforward affair. I think the easiest way to do it probably to get a little flat blade screwdriver, sort of get that under the side of the wire there, and at the same time as you heat this up to pry it with the screwdriver. So basically like that, and then you can take a pair of pliers or something. Just bend this straight up and do the same on the other side, obviously. So let's get that in there. Fortunately, it's fairly easy to take off. It's not a big sheet of metal, it's very thin, so it heats up easily. So there we go, that just comes off like that. So that's the bottom side of the board there. Optoisolator is over here, and I think yeah, there's the other transistor here, is that one there. Looks like could be an IC, but it's actually a transistor in that package there. So that's one side of the oscillator, and the other transistor, of course, is the actual main switching transistor there. So it's all a very simple sort of approach. What is interesting, I noticed, is that the board manufacturer's marking, this logo here, which kind of looks like, you can't see it because it traces the way, it looks like NP spelt backwards. Fascinatingly enough, that logo is the exact same logo that I saw used on the blank FR4 PCB material that I bought from Dick Smith Electronics years and years ago, when I first started making printed circuit boards for myself. So it's quite fascinating indeed. Let's just discharge that main filter cap just in case it's still charged. 100 ohm resistor on there. That'll do. I mean, it's probably discharged anyway because I pulled out the mains cord while it was still plugged into the lights, so that would have run down the charge on the capacitor pretty much straight away anyway. But yeah, always a good thing to watch out for that. You know, if that is fully charged, it's not fun to stick your finger on there. I mean, most of these power supplies have bleeder resistors across the capacitor to discharge it anyway, so that, you know, by the time you've taken all the screws out and you've taken the case open, then, you know, it should be discharged really. But of course, if those resistors fail, then you may still have a charge in there or something, but typically it's not a big deal. So I need to use the desoldering gun to get this out. It's a double-sided board and I don't really want to risk destroying anything, so I'm going to use this. So let's just get that. Now, let's see. And I'm going to have to hold it in place while I do the last pin, because if it falls out while I'm desoldering it, it won't actually suck all the solder out. There we go. That should be alright. There we go. So it's kind of hard probably to see in here. I'll just get my torch. So you can see the hang on, let's see a better angle there. So you can see the optoisolator just below that bracket that clamps the main transistor down onto the heatsink there. Kind of hard to see, it's all buried under there, and might be fun trying to get the new one in. Actually, I might have to take that coil out again as well. I'm not certain, not sure. But yeah, you can see it from that side there too, I guess. There we go. I'm just going to flip this out. A screwdriver. Oh yeah, well, it's come out. It does actually look like a little bit of discoloration on the trace that goes from that one pin of that coil to the transistor. So I don't know if it's a problem as well. I've scraped away the solder masks from that trace where it connects to the coil and also to the optoisolator, and they actually look pretty clean underneath, so I don't know if you can see that bare copper there. So it doesn't look like that's a problem. So I'll put some fresh solder on top of that, just to make sure it doesn't corrode away, but I mean, I think it's actually pretty much fine. Tin the top side of this trace here. And the same with this one. Yep, that looks good. I'll have to clear those holes out again though, but you know, that's a good connection. So if that if the corrosion on that little trace there for the optoisolator was the problem, that's not going to be a problem anymore. So that'll be a good connection there, and we'll have a new optoisolator without any corrosion on its pins. So, you know, if there is still a problem after that, I suspect the problem will be something else. But I'm pretty sure that that's what it is. Right, so I'll put a new one of these in. Just being aware that my camera is about to run out of time, so I'll have to restart the recording in a second. Yeah, so interestingly enough, the new optoisolator has a sort of shorter body than the old one. But of course it is the same model number and everything, it's just a slightly different package. I guess that makes them able to save a little bit of plastic or something. And, anyway, we'll put that in and see how it goes. Just making sure I get that around the right way. So the pin 1 is in this corner here, towards the heatsink that way. Making sure the solder flows through to both sides. And let's just check that. Yep, that looks pretty good. Everything looks very good. I'll just solder it on the top side as well, on that pin. So there we go, got a nice shiny connection there. So I mean, yeah, if that was the problem, then it shouldn't be the problem anymore. So I can get this coil through here. There we go. See, that should be all good. Now obviously you don't want the leads sticking out too far on here because we have to put this shield back on, so that we don't want to have those punching through that plastic and shorting out on the metal there. But yeah, that looks fine. So I put the transformer back in now. Should be alright. No, the coil is coil's too close to the transformer now. It's alright. The transformer pins don't go very far through the board, funnily enough. But anyway, I'm gonna do holding that in. Now, which pin did that ground wire connect to? So that was one there, I think. Yeah, that one there. Okay, so as I can see, it was that one there. So now that's everything, I believe. So I can stick this back on there like that. Bend those over and solder them back on. It seems to work. Let's see, the best test of this will be to see obviously if it works when it's cold. So let's see if it works when it's just as it is first. So just gonna put the lid on in case anything explodes. Now I plug my lights in here, so it'll be obvious when I plug this in if it works, because you'll see the lights come on. So let's do that. The lights come on, so that's good. So you can see, just wait for that power light to go off. So now if I take my freeze spray and I freeze that optoisolator and everything around there, that's pretty cold. Now with this one, that should completely stop it working. In this case, it should still work. And it does. So I guess you'd say that's probably fixed. Now I should get rid of all that ice. Alright. So there we go, that does in fact seem to work now, and it also works even after you give it a good liberal dose of freeze spray. So looks like the problem is now gone, and most likely was this optoisolator. I dried this out just quickly with my hot air tool. Obviously after freeze spraying it, it will get some moisture on it, so you don't want to leave it like that and put it back in the box. It'll just cause the corrosion problem to happen again. So yeah, you want to keep it nice and dry. So put that back together. I think I'll only bother with the one screw. It's not like it needs all three, and I don't entirely know where the other two actually are. I think they're up here somewhere, but anyway, it's irrelevant, so you can fix that later. So yeah, that's all good. That's about it. Temperature dependent faults can be quite annoying, but if you can narrow down the part and use freeze spray and hot air and stuff to alternate and get a sort of a consistent working and non-working state between hot and cold, you can track it down sometimes quite easily. Otherwise it can present as an intermittent fault and be a lot harder to figure out. That's the worst kind, intermittent faults. And the intermittently intermittent faults, they're usually caused by some sort of bad connection somewhere internally in a component or in a solder joint or something. But anyway, that's probably it for this one. So thanks for watching, and I'll see you next time.